Hi there. In today's tutorial, we're going to be looking at Serial.print line function. Okay, you're going to be using that a lot in your coding as you go on, as you progress in the future. Okay, so when creating when using the Serial.print function for Arduino, there are a few objectives that we have to go through and make sure that each one of them has been met by the end of this tutorial. So so the first objective is introduction to serial communications. So what is serial communication? We'll go through that. Okay, I'll explain the basics, and then the second thing is understanding the function serial.print. Okay, we'll go through the purpose and the functionality of the function. All right, the next thing would be the third objective will be the syntax and parameters. Okay, so we'll go through the different data types that can be printed outside that can be printed inside using the serial.print function. Okay, the fourth objective would be printing variables. We'll print variables and demonstrate how to do that with different data types. Okay, the other objective is special characters that are in the serial.print function that you can use. The seventh one would be the serial monitor. So we'll go through how to use the serial monitor. I guess at this point you've seen a sneak peek of the serial monitor. So the eighth one will be troubleshooting and debugging, the common issues that may arise when using the serial.print. Let's get started. So we said that we're going to, the first objective is explaining what serial communication is. So this is a method of transferring data between two devices using a serial data transmission protocol. Okay, it allows for the transmission of information one bit at a time over a single communication line, typically using two wires, one for transmitting data and the other for receiving data. In the context of Arduino though, serial communication is commonly used to exchange data between an Arduino board and a computer. The Arduino board communicates with the computer through a USB connection, which usually emulates a virtual serial port. Okay, it's a USB, but Arduino recognizes it as a serial port. This allows you to send and receive data between the Arduino and the computer program running on the computer, such as the Arduino ID or a custom application. So you might ask yourself how exactly you're going to get your code to the chip itself. So it's through the serial interface. Okay, all right, so there are a few elements involved in serial communication. So one is UART. It's an abbreviation for Universal Asynchronous Receiver Transmission. Okay, UART is a hardware module found in most microcontrollers, including Arduino boards. It handles the conversion of parallel data in multiple bits to send serial data in single stream of bits and vice versa. So just know, for now, it's just a transmission protocol for handling serial communication. The other thing that's also very, very important is the baud rate. Okay, baud rate refers to the speed at which data is transmitted over the serial connection. It represents the number of bits per second that can be sent or received. Okay, the Arduino and the computer must have the same baud rate settings to ensure proper communication. Common baud rates include 9600, 115200, and others. Okay, I'll demonstrate that here. So to get started, serial.begin on the setup function. So this is my Arduino ID. Okay, and then we set the baud rate the speed that you want to communicate with. Okay, so at this one we're gonna do, let's do 115200 bits per second. Okay, so anytime we do serial.print, because this is the function that we're discussing, and then let's call this hello world. Okay, so the first thing to do is to verify if the code is okay. So let's save it, serial. I'm gonna call it serial.com. All right, so it's compiling there here. All right, and then I'm gonna upload it once I've compiled it. Okay. All right, and then I will open the serial monitor. So is it? Yes, this is a serial monitor. So as you can see, things are a bit faster, so let's delay things a bit because we cannot see clearly what's going on. So let's do a delay of 1 second per print. Okay, uploading, compiling. See, it's printing every second. All right, so you notice this is the baud rate. It has to be exactly similar to this one. If I change this to something else, you see, we are just getting gibberish. All right, it has to be 115200 as the one I set in the code. If they're not the same, you are not going to communicate between the board, the chip, and the board itself. All right. The other thing, the key elements involved in the serial communication is the serial port. So you have to specify which port you're communicating with through the ID. So right now, don't worry about my chip. This is my port. So I'm using Linux. In Windows, you'll see COM1, COM2, COM3, COM4, something, but mine is Linux. So there's dev, TTY, USB 0. On Mac as well, there are different naming for the ports. So it will depend on the operating system that you're on. But the same, you'll just have to specify the port. All right. Okay. The other thing is the serial monitor, which is this, the one that we've just pulled up. So you can set up the baud rate, a few things you can do. You can also like show the timestamp for each data. Wonder why it's not showing. But yeah, you can show timestamp, and this is where you see what's going on in the board. This is the window to the chip. Okay, this is what you are going to see. It's what's going on in your program. Okay. Yeah. Okay, so as we just said, to establish the serial communication between your computer and the chip and the board, you have to start with a serial.begin function and then specify the baud rate. Okay, the next you're gonna call serial.print function and print whatever it is you want to print to a serial monitor. Okay, other than that, this is for sending information from the board to the computer. You can also receive information to the chip from the computer. Okay, yeah. So one of the most common uses of serial communication is for debugging purposes, sending commands, receiving sensor data, and controlling external devices. It provides a simple and effective way to exchange communication between the Arduino board and other devices or programs, or even programs. Okay, so I think the best thing we'll do is do an example. Okay, all right, so we are going to go to is printing variables. Okay, so let's define a variable here. Let's call it, to define a variable you have to start with the integer and then the name of the variable. So let's call this var. I'm just gonna call it number. Okay, and then store 12 inside there, and then printing it out. Okay, so if I get rid of this, if I upload it, of course it's going to compile first. Okay, so we declare the number up there and then we print it through the serial.print as the name of the variable. So you'll see number 12 is being printed out after each and every second. All right, great. So the other thing that we're going to look at are special characters. The special characters that you can use in the serial.print function. Okay, so for instance, if I have, let's go with an example. So let's do hello. I'm gonna do hello there. Okay, so those are two strings that I'm trying to print out. Let's see how they appear. So you see all of them are they're together, like jumbled up together. Okay, so there's a special character which, if you've been programming by now, you know it. In case you don't worry. So this is a new line character. Okay, so the new line character introduces a new line in between two of these strings that I'm trying to print out. So let's just see how it all looks. Okay, it's uploading. You see, so there's a space between each and every string. So the first string was hello, and then a new line character which pushes the next there. But then since we don't have the new line character just before hello, it's going to touch each other because it's a loop. So let's introduce a new line character up here like that. Okay, you see, now you got some space in between the strings. So an alternative to this, let's comment out the new line character, for instance. So to comment, you can just do that. An alternative to this, you can print ln. Okay, so print ln automatically creates a new line character after the variable has been printed. So you'll see how it all looks like. So right now we've done print ln on this string. Okay, this means by the end of this string there is a new line character. It's going to push the cursor to the new line and then print out, because this one didn't have a new line character, so it's touching this. Hello didn't have a new line character, so it's touching this other string. So if you do an ln here, okay, it's loading. See, it's the same as the one we did before. Alright, the next character we're going to look into is the tab character. Let's just show you how it's working. See, there's a space in before there's an indent. It introduces an indent between the first point where the string is going to show up and the new. So there's a space just before you type it out. So you can do something like that and then show it out. So this will introduce a space in between hello and there. like that. See, but now there is coming on a new print, but there's still a space in between them. Okay. All right, guys. So more of this, you will be using the Serial.print more and more in the future. So I think this is it for the basics. I don't want to get too deep into it because this is basically the holy grail. You're gonna use it a lot most of the time. So yeah, okay, thank you guys for watching. If you haven't subscribed, please subscribe, and see you guys in the next one. Thank you.